All right, so in this video, we're going to go over a few things that can help with sort of having a more object-oriented flow in your Odin code. Now, I want to say this at the beginning of the video that I'm not advocating for doing any of these things necessarily. I'm saying here's how you can do them when you need to or want to, right? We're going to be essentially looking at how can we use some of the tools that Odin has for dealing with things that are common to multiple different types of things, for example. Things that should be guided by the actual object itself, as in we have runtime polymorphism. The object itself decides what code to run in some sense, right? Or it's decided effectively at runtime, right? And so on. So we're going to take sort of brief looks into this, look at some of the tools that Odin has for dealing with this, right? So we have a fairly contrived example. We have a user struct here. What we're going to be doing with this user struct is basically we're going to log this user struct. So for example, if I were to say, use kind of the quote unquote normal ways of just doing stuff like this, I might say that we have user log, which is a proc that takes a user and just sort of prints something, right? Like this. Actually, let's say user log here. This is of course just normal bog standard stuff, right? When I do this though, we can see that, we just print the user, right? But when I'm logging stuff, and certainly nowadays we have to be careful with this and so on, we may or may not want to actually redact some information, right? So we have to say social security number equals a redacted, right? And of course, when I save now, this is not going to compile because we cannot assign. So we have to take a pointer, right? Which means we have to also go down here and say, okay, this is now a pointer to you. So when we run now, we will see that social security number is now redacted, right? So now we could potentially log this and have it be stored wherever, really, right? Because this personal information is basically gone from our system, from the log, that is. And this is all fine. I mean, this is what we could do if we have just a user here, right? Sometimes we might want to have some kind of function that logs something. It doesn't actually know what it is though, right? And now things can become a little bit complicated, right? So for example, if I say log redacted is a procedure that is something, right? What would that even really be, right? We can't actually just say, oh, I have a user, right? We have more things than users, and certainly we want to log more things than users and so on and so forth, right? So this might get a little bit complicated, right? But what we could do in this particular case is we could basically put this information in the types themselves, right? So let's say, for the purposes of this, that we had some value here that was L, which is a pointer to something loggable, right? Now what is loggable? Well, we're going to look at that, right? And here we would say L, let's say redact like this, right? And we also have to have L here. We want to perhaps format the thing we're doing, right? Because not everything is going to be just straight up, just like this. So let's say fmt printf with v with a new line, L format L, like this, for example, right? Now we have basically two desired things. We have some kind of formatting. This should be, actually, let's just say that this is a string. So format should return a string. And redact in case something should be redacted, right? So when I save now, of course, nothing knows what a loggable thing is. We don't have redact, like we don't know what that means and so on, right? Let's say that loggable is a struct that contains some actual functions, right? So in our case here, we actually want redact, which is a proc that takes a pointer to something that is loggable, and format, which is a proc exactly like this, right? Now we have this this is basically now an interface, right? You can see this is just a struct that contains function pointers, right? So how do we actually deal with this now, right? We can add to our user, right? We can add this loggable thing here, right? Something is loggable like this, right? And now when we create our user, we actually have to say loggable is loggable of some stuff like this, right? And here we might say, for example, redact is a proc that, let's say user redact like this. And format is user format. And now we're going to implement these. Here I'm just going to repurpose this now. This takes a pointer to user, and redact needs to take a pointer to loggable. So we actually take a loggable thing here, right? And then we cast, right? So this should remind you of what we've done before, right? Right, now we cast this L to pointer to user. We redact, and then we don't print anything. User format proc L loggable. This of course returns a string, right? So we actually have to add this here, and here we want fmt tprintf, for example, right? We can try that, right? User with name, sure. For ease of use here, let's just say %v, right? And here we can cast this L here. Now this looks vaguely like something we want. User log is no longer defined. We're gonna try log redacted on the address of u, right? Let's see. Missing return statement, right, return this, indeed. Right, this is u loggable. I think that should be fine. And here we can see, right, we are now logging this pointer to a user, and we can see that our social security number is redacted, right? At no point in this flow here do we actually do anything like that. We are redacting in user underscore redact, right? Now, there are a few redundancies that are happening here, right? So for example, in log redacted, we have this interface, right? Pointer to a loggable thing, right? One redundancy here is that we are definitely we're calling this function that is attached to L here, right? And then we're passing L to it. This is a slight redundancy, right? So what Odin actually allows us to do is use this selector operator, which implies the other version. So if we copy that one to illustrate, right? This here, this line, turns into this automatically, right? So I can do this now. I can do this. We don't need to pass any argument there at all. And this still compiles. And now it still works, right? So when we have something that looks as follows, right? Thing dot method dot thing pointer to thing, right? When we have that, we can turn that into thing dot, or arrow rather, method. Those are the same, right? So, right now we have this log redacted, right? We're taking a loggable thing. So anything that has these, we're gonna be fine, right? Another kind of small thing here that is a little bit annoying is that we have to have this loggable here. We have to take a pointer to the loggable section here, right? There's a slight kind of, there's a way a little bit around this that we can use. that instead says it's using the using keyword, right? So using loggable here. First of all, I can save now, and here we can see, that is a syntax error. There you go. First of all, we can see nothing has changed here. And does this actually work still? It does, right? And that's interesting, right? Because we haven't really changed anything. We said using here. One of the effects of actually being able to, of doing this now is we can actually say redact is equal to user redact and format is equal to user format. And this is now, it still works. The reason for this is that using, when you use it in a struct context, right, actually basically injects the fields of the thing you're using. So our loggable here, of course, has redact and format, right? This is as if we said basically redact like this, right? And format, basically those two, right? The fact that we're using here makes it so that, yeah, we can just have this, right? And so using here makes it possible for us to just sort of say this. Now we can take a pointer to you and everything still works, right? And there's a slight thing, let's hope I can show this. There's a slight complication here that is a little bit awkward. If you saw what I did here, right? I put using loggable at the end, right, of this object. And the fact that I did that means effectively, when we take a pointer to you, right, what actually happens is that we get a pointer to name because that's the first field. So suddenly when I put this first, this works, right? This is because you can view this here as a table of functions, right, that have the same order as this. That table of functions is first in the actual object, right? And so that virtual table, as they call it, right? When we take a pointer to you, we are indirectly taking a pointer to that table of functions, right? So when I pass a pointer to you here, bam, we actually get a pointer to this table because it is first in this, right? And so that is something to kind of keep in mind. This is something you can do. All of these things you can do, by the way, in C. Of course, you're not going to necessarily get the syntax sugar, right? But fundamentally, vtables are completely language agnostic at the end of the day, right? These virtual tables with functions and so on. It's something you can use in any language. And certainly we can use it in Odin, right? One thing that is potentially interesting here, if you choose to do it, right, is that you can effectively have multiple steps here. So we can see here that a user is something that is loggable, right? When I say using loggable here, in effect, what that actually means in some ways is that we are, in some sense, we are inheriting these fields, right? We're just sort of inheriting them. They're ending up in our structure, right? We can actually do this in several lines, right? So just to illustrate what that means, redactable is a struct, right, that has a method on it, or a function rather, right, like this. Loggable is going to say using redactable, which is a redactable like this, right? Let's see here. And now user redact, of course, takes a... And now we're getting essentially the same behavior, right? We're still redacting. And of course, now basically loggable implies that something is redactable, right? And so we can do this in different stages, right? We can effectively build up an inheritance hierarchy in some ways, right? Where we basically, I think some of this will be kind of clearer when we actually look at some examples. So we're going to do that fairly soon. But yeah, basically, we can have these hierarchies, right? Of different kind of obels, if you will, in line, right? And so yeah, this is how we can kind of establish that relationship. And of course, redact and format here are entirely, we can pass whatever, right? In fact, we can change them at runtime if we so choose, right? We could have one user redact that's set a certain way. We could have one user redact that's set another way. We could switch the format that it should use. We could of course have a nil redact for, you know, test users in dev, for example, right? So user nil redact, let's say I have a proc L redactable, this should be R by the way, like this, right? Here, if I wanted to, for example, do nothing, I would just do nothing, to be honest, right? We could delete code here. We could effectively do nothing here. And based on the flow of the program, a user actually might, you know, get something else, for example, right? If I now set user redact to nil redact, we should see that, yeah, this is not redacting anything, right? And this is instead kind of, we are now essentially just attaching this function pointer to the object, right? To let it be resolved there, right? And to be clear, this is not necessarily going to be fast, right? Where there is a pointer dereference, right? And so on. So we should be aware here that this might not be for a hot loop, for example, right? But it does allow you to do, you know, something different based on behavior, right? In many cases, what you want is not necessarily an open set like this, right? So just to clarify what I mean by that, this is an open set of types, right? This loggable thing here, meaning code can decide to implement it and sort of join the set, right? We can add members of that set of things, right? In our code, wherever, right? Anything that implements loggable is now part of the set of types, right? The set of the members of that set, right? A closed set, on the other hand, would be a union, for example, right? Int, surely loggable, right? String is loggable, float, etc., right? But importantly, I cannot just add my type to loggable things, right? Unless I control the source code, right? So when you implement someone else's interface, right, that is you effectively, in some ways, joining that set of things, right? You're adding something to that set of things. It's an open set because it can be added to, right? Which means we can never know what is part of that set, right? It is impossible to know because something could, well, in this particular case, you can see at runtime, in some sense, something could be added to the set even, right? So, you know, you don't always want an open set. Closed sets are very useful. I would argue they're useful in more scenarios, of course. We usually have some set of things this thing works for. All of our errors should very likely be this, right? We don't want dynamic errors necessarily, right? We want all of our errors to be clear and lined up, you know, lined up. Like this function can emit these errors, right? And if we do have some openness, it probably has a well-defined structure and we can explain it in terms of a closed set, right? But that still leaves, yes, we can do these things. We can say something is loggable, which means it is redactable, right? It has a format, it has a redact, right? And then we can write functions based on these contracts, right? And of course, log redacted here could basically say, you know, check for nil pointers basically, right? If L format is nil, for example, right? We could assert like this, for example, right? We could assert both of these, right? And this would allow us to basically catch stuff like this, right? So, for example, if we run this now, nothing happens, right? That's all fine. Let's say we didn't set redact. We had a code path that didn't set any of this, right? We would get a runtime assertion, for example, right? So we can actually support dynamic stuff here. We could, for example, even say, you know, if, let's see here, let's say nil redact. Yeah, actually, I'm gonna rename user nil redact, right, to just nil redact, right? And so now, for example, we could assert that yes, format needs to exist. If l.redact is equal to nil, l.redact is nil redact, right? So now, remember, we are not setting redact here, right? We're omitting redact entirely. But when we run, nothing happens, right? So we have dynamically decided to add effectively a dummy version of this, right? So there's lots of stuff we can do here with this kind of stuff, and we can effectively code to the interface, as they say, right? And get this, right? It is entirely doable, right? And we can even get some of the syntax sugar that might be nice here, right? L arrow redact, right? And remember, this is of course this, right? But we don't have to do that. We can just say this, right? So let's take a brief look at sort of the standard library and where some of this shows up. Some languages, of course, basically work like this, right? They work in an object-oriented manner. And it can be important when dealing with those languages that you have something that actually mostly works kind of the same, right? And the kind of dirty secret is that these vtables and so on, right? This is effectively how things are done regardless. If something is not compiler driven, as in the compiler chooses an implementation of something, right? It is going to be basically vtable driven, right? Where we actually have a table of functions that resides in a certain place so that things kind of work out, right? So let's take a brief look at the Direct3D interface in the standard library, right? We will find these vtables everywhere, right? So let's pick a random one, right? I'm going to search for underscore vtable. This is the naming convention they have chosen here, right? We're going to pick one that sounds interesting. Device child vtable. Let's say that, right? So first of all, we can see here that a device child, iDevice child, right, is a raw union, and we're not going to go over that so much right now. But what a raw union is effectively a C union, where the same type, the same data rather, can be represented with different types. And depending on the one we choose, that is the representation that's going to be interpreted at the time. If that sounds a little bit obtuse, we can probably look at this in another video at some point. I don't think it's super, it's not super deep, but we'll take a look at that at some point. So we have this subtype directive here, and I'm not entirely sure what that is about, but the important part is we have this vtable that we're referencing here, right? You can see here that itself is referencing another vtable, right? An ID3D12 object vtable, right? This iObject vtable, right? And then we have get device, right? So this particular section, device child here, right, is basically providing this. And you can see here it takes a this parameter, right? As we would, for example, in C++, right? Which is a pointer to exactly the thing that we are working with here, right? When we look at this now, you can see here, this itself is also using another vtable, right? So we recursively, or not recursively, but we are effectively nested, we're using nested vtables here, right? So we can see that an object vtable contains get private data, set private data, set private data interface, and set name, right? And again, these are all, they have this pointers, right? that reference this I object thing, right? This I object thing is of course here, and it looks much like the other stuff, right? This is a subtype of I unknown, right? So if we go to the I unknown vtable, we can actually find this here, and we find that, we have reached the last turtle, so to speak, right? Here we have this query interface, add ref, release, but we are not referring anymore to any sub vtables, right? So here is where this stops, right? And this means basically that when we were up here, iDeviceChild, sorry. This means that a iDeviceChild is an I object, and an I object is an I unknown, right? That is the relationship. What this is effectively just a big, well, not big, but it's an inheritance hierarchy, right? And this is, you can model this exactly like this, right? If we find, for example, we could say using, let's say like this, right? Using w plus colon I device child, right? Now we're seeing something here, right? So now I'm searching for this thing, right? So for example, we could see what is a subtype of iDeviceChild. We can see that an iResource vtable is in fact that, right? That is a device child. So we've gone up even further in the hierarchy, right? So something is a something is a something, and so on, right? This is a device child. A device child is an object, and so on, right? And this is, of course, the nature of these inheritance hierarchies. So you can see here how using effectively allows us to, in some ways, emulate this kind of relationship or represent this relationship, right? And that all of these functions, right, they work exactly the same way, where they have this pointer to the thing that we're talking about, right, as the first argument. And if you, for example, have seen Python, you'll know this from Python as well, right? That this is how they do it as well. A method takes as its first argument the thing itself, right? Or, for example, Rust might work like this, right? And so this is how we can represent this, right? And this is used in several places. Like, for example, if we go to the metal interface, let's see here. Actually, one of the best ways of finding this, right, is to search for using and then some kind of word that can be as long as it needs to be, something, and then we can say, for example, pointer to something. We don't need to do that necessarily. I found some good examples before, which actually we can say event, maybe. Yes, maybe. Let's see if we can find this here. Shared event is using event, right? Yeah, okay, so here we can actually see that we have a different way of kind of doing it with Objective-C, right? So an MTL texture here, right? Texture in this code is a resource, which is an object, right? Which in itself is an intrinsic Objective-C object, right? If you go to this, you won't actually find it. We will get nowhere, right, if we go to definition on this, because these intrinsics are effectively just provided, or they exist in the actual compiler. It is just some kind of, you know, detail about how this is structured or whatever, right? But yeah, this is obviously Objective-C, which is of course another, you know, object-oriented language, right? It is perhaps even more object-oriented than C++ for sure, right? In that they do even late binding to the extreme, right? Whereas C++ is perhaps mostly this kind of compiler-driven inheritance kind of way of thinking. But yeah, so this is basically how we can do this, right? So if we go back to this, we can see that there is some level of inheritance kind of going on here, where we are saying something that is loggable is something that is redactable, and here we have reached the end of that, right? And we can write functions for those interfaces, right? So I can say log redacted here, right, is taking something that is loggable, right, a pointer to that, and saying, if we don't have an implementation of redact actually, I can actually add one, right? And you can imagine this can be code that does anything. I mean, for all we care, you can download a DLL or a shared library from the internet and call a function there. You know, this is the kind of, when you do this in some ways freehand, right, you actually gain an immense amount of power in some ways, right? We're just talking about function pointers here. And of course, you have the power to do the wrong thing. So it's not always great, right? But you have this ability here to kind of, when you're using this late binding, late kind of, hey, does this exist or whatever, we actually can do things that you would more associate maybe with languages like, let's say, Ruby or something, where we can detect that a method doesn't exist. And we can actually create that method or something, right? We can have special behavior based on that, right? And of course, we can also assert here to say, hey, you know, you're trying to call format, or you're going to, and this is actually nil. I actually need this to be something, right? And so on, right? So there's lots of stuff you can do. I think that, again, I don't want to kind of push here too hard and give the impression that you should be doing this all the time and so on, right? But there are code paths in your program that definitely are not going to fall apart because you're going through a pointer when you're making this call, right? That is not necessarily the case. Of course, in the ideal situation or whatever, you might want everything to just be, no, everything is, you know, highly specialized all the time. There's no pointer chasing for any of these functions, and that's fine, right? But this is available to us, so it could be something that you could use in certain scenarios, right? So here's how we embed this loggable kind of table of functions, right? And here's how they have this inheritance kind of structure between them. Here's how we use this, right? We just code to that interface and so on. And when we actually create our object, it is as simple as just setting the fields, right? Because of using like this, right? And so, yeah, with that, I think that's basically everything about these things that sort of fits here right now. If you have any specific questions, absolutely just ask them, and I'll see if I can sort of help. I don't necessarily do stuff like this very often. It just doesn't come up, obviously, as often as just having functions that work on specific structs and so on. And a lot of the time we can, of course, get away with just saying, I have some data pointers, I have functions that cast those data pointers and so on, which is a little bit kind of like the thing that we're doing here, right? User redact is taking something that is redactable, casting it to a user, right? So in some ways, this is a specialization of that behavior, right? But yeah, with all of that said, right, this is how we can do some of this stuff in Odin. I hope that this has helped to kind of clear up a few things. I hope also that the section about the vtable here, right? Certainly I would recommend, if you're interested in that part, absolutely look into this forward, more, right? And you'll fairly quickly realize that, yeah, this is actually kind of what's going on, for example, in C++, right? We have this vtable, it has functions associated with it and so on. And when an object is created, in some sense, it is just filling in these functions, right? And in removing some of those kind of conveniences actually gives us a lot of power to some extent, right? Because you can see here, we have what is very dynamic here, right? We could choose a version of redact, right, for redactable entirely based on whatever logic we want, right? Doing the same thing, for example, is something that is a little bit more rigid, right? actually might be more difficult, to be honest, right? We might not have the same kind of capability there, right? To do something that kind of makes sense. In some ways, we have to fill our inheritance hierarchy with interesting things instead, right? To say, oh, well, there is the default method for this and that, right? But here, we could literally just contact the database to ask how we should redact this. We could download a binary blob with a shared library, like I said, load the function from it, and then execute that function if we so choose, right? The world is your oyster at the end of the day. And this is in some sense kind of maybe the difference here between this type of object-oriented programming and let's say the Java version or the C++ version. This one is much more, in some sense, free, right? It is a little bit more relaxed. It is not about the rigid structures necessarily. It is much more about, well, these are just function pointers. They could be wrong even, right? And that is a risk that some of you may die, and that's a risk I'm willing to take, right? That's kind of what Odin or some certain languages are saying here, right? Where it's more like, yeah, these are just function pointers. You are responsible, right? And I think that's both interesting and a little bit like, well, slow down, right? But yeah, so I hope this was helpful, and I do recommend looking into some of the specifics of these types of things, and seeing that most of it is just very simple when you get down to it, right? These vtables, for example, a virtual table sounds maybe a little bit daunting, a little bit like, oh, that's scary. That sounds like a computer science thing. I'm just not that kind of guy, right? But it's really not, right? It is just function pointers with a fancy name, right? So yeah, again, hope this was helpful, and I'll see you in the next video. Have a nice day, and ciao.